Welcome to springlib.
Okay, in this problem we have a flat disk of radius r naught and total charge q. We're given its potential in terms of q and r naught of x away from our disk, and we are asked to find the electric field in the x direction. So to start us off, the relationship between electric field and potential is given as the negative gradient. So let's jump into it. So the gradient in 1D ends up simply being a function of x. The gradient is the negative just first derivative in x of our v potential. So we have the negative first derivative of this large expression that we were given, q over 2 pi epsilon naught r naught squared times x squared plus r naught squared to the 1/2 minus x. So doing this integral in x is actually relatively straightforward. We can do a little bit of product rule and maybe even a chain rule. And we will end up with pulling all the constants out, first of all, q over 2 pi epsilon naught r naught squared. We're left with just some remaining stuff involving x. And this will simplify down to negative q over 2 pi epsilon naught r naught squared, the same constants as before. We have 1 minus x over x squared plus r naught squared to the 1/2. Also, this negative sign is gone. And that's it. That's the expression. Now we're asked to plot these in this new variable. So if we let this new variable, call it big X, equal x little x over r naught, we can reformulate Vx as q over 2 pi epsilon naught r naught squared multiplied by the square root of big X squared plus 1 minus big X. And similarly, we can do the same thing with our electric field. So q over 2 pi epsilon naught r naught squared, 1 minus big X over root big X squared plus 1. And we can plug in some our values for q and epsilon naught and r naught for the problem as suggested, and we will get some numerical values of 9 times 10 to the 5 volts times the portion with our variables in big X. Similarly, we will have the constant 9 times 10 to the 6 volts per meter times stuff in the parentheses. And these were our numerical expressions. So we finally can plot some stuff. So our plot out to 4 of these units will look like this. It'll go from 1 to 9, and it will fall off as so. This is our plot for the electric potential. For the electric field, we also have something that falls off. And it also starts at 9. Oh, also worth noting, these are in units of 10 to the 5. And these are in units of 10 to the 6. And those are ultimately our plots. And that's it.